These are the 7.5 notes, and today's objective is we're going to factor perfect square quadratics. And perfect square quadratics look something like this, where we've got something like x squared minus 16. And what makes this a perfect square quadratic is both the first and the last term are perfect squares. X times x is x squared, and 4 times 4 is 16. So those are both perfect squares. And if you'll notice, there's no middle term. So we could rewrite this to be x squared plus 0x minus 16. So when we're thinking of factors here, we're thinking of factors of 16 that would add together to be 0. So these are really easy to factor because all you have to do is take the square root of each. So it's x plus 4 and x minus 4, because 4 times 4 is 16 and 4 minus 4 is 0. So here on number 1, I've got two perfect squares, and so we're going to factor this perfect square quadratic. It's a binomial because there's only two terms. And always when you're doing perfect squares, all you have to do is take the square root of each. So x times x is x squared, and then 11 times 11 is 121, but we need one of those 11s to be positive and one of those 11s to be negative so that we don't end up with a middle term. 11x plus negative 11x is 0. On number 2, same thing. I've got two perfect squares, 100x squared. The square root of 100 is 10, and the square root of x squared is x. And then, so I've got 10x times 10x, which makes my 100x squared, and then plus 1 and minus 1, because 1 times 1 is negative 1, and then when I distribute, I'll have negative 10x and positive 10x, which will be the middle term, 0x. On number 4, just because this is a fraction doesn't mean it's not a perfect square. Remember, the square root of a fraction is just the square root of both of those. So I've got x plus 1/6, because the square root of 1 is 1, and the square root of 36 is 6. And then I have x minus 1/6. So that's the factorization of that perfect square binomial. And then on number 5, I need to change this around so that I've got x squared minus 64. And again, those are two perfect squares. So I want to factor this into x plus 8 and x minus 8. Because 8 times 8 is 64, and 8 minus 8 is 0. Okay, the only other problem that we need to look at today is number 11. This is the last problem of the day. And I've got an object dropped from a 729-foot tall tower, and the height of the object is represented by the expression 729 minus 16t squared, where t represents the number of seconds. So in part A, we're trying to find the height of the object after 3 seconds. So remember, t is seconds, so that means that t is going to equal 3. So I'm going to substitute in my expression, I'm going to substitute 3 in place of t. So I've substituted 3 in place of t, and now I'll simplify. Taking care of my exponent first, 3 squared is 9. Then I'll multiply 16 times 9 is 144. And 729 minus 144 is 585 feet. So after 3 seconds, the height of the object is 585 feet from the ground. It started at 729 feet from the ground, but it's dropping at a rate of 16 feet per second squared. Now, I'm going to do B the same way. This time I'm going to replace the t with 6. So replacing the t with 6, I've got 729 minus 16 times 6 squared. 6 squared is 36. 16 times 36 is 576. Then I'll subtract, and 729 minus 576 is 153 feet. So after 6 seconds, the object is 153 feet to the ground. Now in part C, they want us to estimate when the object hits the ground. So when is this object 0 feet from the ground? Well, I can see that after 3 seconds it's closer to the ground, after 6 seconds it's even closer. So I'm just going to keep trying numbers until I find a number that makes it equal 0. So I'm going to try 7 since 6 was pretty close to the ground. So I substitute 7 in place of t. 7 squared is 49. 16 times 49 is 784. And when I subtract 729 minus 784, then I get negative 55. So after 7 seconds, it's actually hit the ground. It's actually hit the ground sometime before 7 seconds because this is coming out to be a negative distance here. So it's sometime between 6 and 7 seconds, and I think it's closer to 7 seconds because negative 55 is closer to 0 than 153 is. So after 7 seconds, then the object is going to hit the ground. It's not quite 7 seconds. Now on part D, we're going to factor 729 minus 16t squared. And this is a perfect square binomial, perfect square quadratic. The square root of 729 is 27. So I know 27 times 27 is equal to 729. And then the square root of 16t squared is 4t. So I want one of those to be negative and one of those to be positive. So I've got 27 minus 4t and 27 plus 4t. So this can be factored because both of those terms is a perfect square.